Hello viewers and my dear students. Welcome to session 2 on problems on one-dimensional truss analysis. Here I was showing you a demo on typical truss problem analysis using Ansys Release 14 of Mechanical APDL. In this session 1, the problem was this. And I've come till the pre-processing stage. That means the modeling had been completed, link 180 element has been selected, material properties has been assigned, real constant has been assigned, and only thing is now we have to go to solution phase. So in the solution phase, that boundary condition and loading and all that will apply. Now we will go for the Ansys Release 14 Mechanical APDL. Now we have come up till this. That means we are at the end of pre-processing stage. In fact, we have even saved this at this stage. That means in case we do any mistake later on, if I do resume DB, I'll come back to this stage only. That is pre-processing stage. That is after making the elements and all that. You can see here list elements. If you do, then that is list elements, attributes, and real constant. There are 4 elements I have done, all with cross-sectional area 0.1, 0.1, 0.1 in that way. Okay. Now we will go for the loading. Okay. Now loads, you take loads, define loads, apply structural displacement on key points. You take this key point and this key point because both are fixed. All degrees of freedoms are arrested. You take all degrees of freedom arrested at these 2 points. Just say OK. Okay. Now this is all degrees of freedom arrested. This is all degrees of freedom arrested. And at this you have a roller support as you see. That is why then for structural displacement on key points, I'll click on this, say OK, but I don't arrest all degrees. I'll arrest UI and UZ only, but the movement in X direction should be there because it's a roller support. In X direction, either plus X or minus X, that the movement will be there. That means I have to allow UX and I'll arrest UI and UZ. That I'll do. This also I have done. Okay. Now I have given the boundary conditions here. UX, UI, UZ. That means all degrees of freedom arrested. All degrees of freedom arrested here. Now here I have allowed UX, but UI and UZ I have arrested. Now you see carefully. I'll go for the force moment. Force moment on key points. See here on this, if I take here, carefully see, it is Fy. At this point, if you see the model, it is Fy and it is in the negative direction. You see here, positive Y is this one. Coming down is negative. That is why here you put minus 2500. Okay, you look to the model what I have given. I have already discussed minus 2500. You just see it is coming down. Okay, at this you have a load of 2000 in positive X direction. That is why force moment on key points. I'll select this and say OK and say Fx. Okay, Fx, it is 2000 newtons. 2000 newtons. It is that this. So you just check the model is this. Okay, 2000 and 2500. I think I have applied correctly. Okay, then you come to this. Okay, once you do all this, okay, you have loaded all this, and you have loaded here. You have loaded here. Okay, now it is ready for solution. Solution, solve. Current load step you do. Just say OK. If you're done correctly, solution should be done. That is, that message should be cut. Solution is done. Just say close. Okay. Now I'll just say file close. Now you see the answers. These answers are very important because these things you are tabulating in your records or in the examination also. You are taking these results and taking the printout of that and giving it to your examiners. Okay. Now the solution phase is over. Now we go for general post-processing phase. That means where we extract the results. See here, first list results. Okay, carefully see here. Nodal solution, displacement vector sum you see. Okay, you got displacement vector sum like this. Okay, we don't know what is this, is node 1, 2, 3, 4 and all that it says. Which is node 1, which is node 2 and all that we don't know. That is why what I'll go do is plot controls, numbering, node numbers on, and even element numbers also I'll make it on. Okay, I'll just say this. See here, now this as you see here, 1 is this, 2 is this node number, 3 is this, 4 is this. Element 1 is this, element 2 is this, element 3 is this, element 4 is this. Now node 1 and 4, since it is, now we are finding the nodal displacement. No, nodal displacement at 1 and 4 it should be 0. As you see, 1 it is, since it is fixed, node 1 it is 0 0 0, node 4 also it is 0 0 0. It is all perfect. And node 2 it should be because it is arrested in uy and uz, there should be only movement in ux. It is 0.38095 into 10 to the power of minus 6. That is the one of the questions what I've asked. How much R moves horizontally at the roller support? That means you should say 0.38095 into 10 to the power of minus 6 meters. Okay, since we all taken it in meters, into 10 to the power of minus 6 meters. Or you multiply by 10 to the power of 3 and convert into millimeter and all that. But anyway, the answer is 0.38095 into 10 to the power of minus 6 meters. That is at this. Then at node 2, at node 3, you have both x displacement as well as y displacement. It is 0.79365 into 10 to the power of minus 7 and 0.3125 into 10 to the power of minus 6 meters in ux and uy. This is one of the very important answers what you have to take the printout or make the tabular column and give it to the examiner. This is very important. This is in fact one of the questions what I've asked. Okay, that is displacement at different nodes, very important one. Okay, this is important as I've said. Okay. Okay, now you see here, now the displacement's over. Now you see here, reaction solution. One of the very important things, reaction solution. This you have to argue a little bit. Now you see here, the reaction solution at 1, the reaction as you know, you won't get the reaction at all. The reaction you can get at 1, 2 and 4 only. That's what you got. Because only at the supports you will get the reactions. That is, it is supported at 4, it is supported at 1 and it is supported at 2. That is why at 1, 2 and 4 only you get the reactions. See at 1, 2, 4 only it is correct. At 1, no, it is minus 158, minus 1583.3, and at 4 it is minus 416.67. Okay, if you add up these two, it should be equal to 2000 newtons what you applied. Okay, you applied 2000 newtons this way, no? At this point you applied 2000 newtons and you have a support. This is at node 1 minus 1583.3 negative. This 4 also minus 416.67. This plus this is equal to 2000. That is why this is negative. This positive x we have supplied, that is the force. At node 2 we have applied in the positive x direction 2000 newtons, and naturally at the reaction should be negative. And as you see, at node 1 it is 1583.3 and node 4 it is minus 416.67. These two put together will match 2000. If you done correctly, you will have the verification done here only. In the same way, you see here, Fy also, it is at 1 and 2. This is 1 at 2. At 1 it is 312.5650 positive. Positive means upward. And 2 also 2187.5 positive means upward. This positive upward will match the force what you have given in the downward direction, that is 2500. See here, 312.50, 2187.5, both put together it will be 2500 only. These two are positive. The what I have given the force for this problem at node 3 was in the negative y direction, that is minus 2500, matching with this. That is why even these answers are also perfect here. Okay, this also you please copy and make it in a Tableau column, and you have to show it to the examiner or write it in the record. Exactly this way you write it. Okay, that is more than enough. Then what we go for, the next one, we go for the element table. You see here, element table you go, define table, add, okay, add by sequence number, SMISC 1 you take, for member forces, apply you do, then again you go by sequence number you go, LS1 you go, 1 comma 2 or LS1. Okay, in that way if you do, SMISC 1 will give member forces, LS1 will give member stresses. You just say close. Okay, this if you do, now you go in the list results. If you go here, in the list results, if you go in the element table data, the important thing, SMISC 1 and LS1 we have defined already. This you see beautifully, you are able to comment clearly. There are 4 elements now, 1, 2, 3, 4. Element 1. Element 1 is this. It is force is 2000. Stress is 2000 divided by 0.1. That is why 20,000 Newton per meter square. That is 20,000 MPa. Not very much. That the structure is not going to collapse because the yield of this will be minimum 200 MPa and all that. In that way, the stresses what are coming upon this structure is very less. Just 20,000 MPa. Okay. It is not much. That is major. Okay. To 2000, and this is 20,000. This is 20,000 pascals only. Okay. 20,000 pascals. But the failure is minimum is 200 megapascals. Okay. This is only 20,000 pascals. Okay. 2,000 divided by 0.1. That is 20,000 pascals. 20,000 Newton per meter square. Okay. That is element 1. Positive means it is, you call it as tensile. Whenever you get negative, you call it as compressive. 2 you see, in the 2 minus 2187.5, it is the force divided by 0.1, it is 21,875 pascals. Okay, that is also, since it is negative, here you have a compressive stress or compressive force. Here you have tensile stress, here you have compressive stress. And node number 3 is this again. 3 here, 416.67 newtons, okay, is the thing. And divided by 10 is 4,166.7 Newton per meter square or pascals. Again very less. And in that way, the structure is never going to fail because of the present loading condition. And finally 4 also, if you see here, 4 it is 520.843 negative. Negative means it is compressive stress here. Okay, 520.83 newtons. It is the force, and the stress is 520.83 divided by 0.1. It is 5,280 to 5,208.3 Newton per meter square or 5,208.3 pascals. Again, a very less thing. Okay, in that way, this is also very important thing. What you have to record in your record books, or you should go give it to the examiners in the examination. In that way, we have done everything. Okay, whatever is needed for this problem has already been done. Okay. See here, this is on animation also you can show. This also you can show the animation and all that if they say. If they don't say, don't show the animation and all that. Because of the loading condition, you see here this being moved horizontally in the positive x direction and all that you can see. Okay, everything is there. Okay, then plot elements. Okay, everything we have done. This is the end of session 2. In fact, the end of the problem 1 given in the manual. Okay, this you please take care of the procedures what I have given to you. Okay, you should look to both the sessions to understand this problem clearly. Thank you very much, viewers, for viewing. Thank you very much.